go. 4 times 3 plus 5 minus 5 minus 2 equals.
Okay.
All right, next one. 9 plus 8 plus 2 plus 5 equals. Yes.
I don't even know.
And then the last one, 12 minus 8 times 3 plus 5 equals.
24.
Who said 17? Autumn? Yes. All right, very good. Numbers 5, 6, 7, and 8. 5, 6, 7, 8. Here we go. 3 times 4 minus 2 times 2 equals. Yes. Marissa? Okay. Next one. 8 minus 3 times 5. I'm sorry, times 3. Forgive me. I keep thinking the answer. 5. Ah! I said the answer. Never mind. Okay, new one. I'm sorry. My bad. 2 times 9 minus 3 plus 6 equals. Yes. Last one. 7 minus 5 plus 3 plus 3 equals 8. All right. Good job. If you are 10, 11, 12, and 13. Here we go. 5 times 3 plus 7 minus 3 equals. Yes. Okay. 3 times 10 minus 9 minus 2 equals.
19?
Yes. Last one. 8 plus 9 minus 2 plus 5 equals.
20.
Yes. Okay, and then numbers 15, 16, 17, 18, and 19. We'll do all of you. Okay? Lucas, what number are you?
17.
Okay, you're up.
16.
Yeah, 15 through 19.
Oh, come on.
Okay, here we go. 5 times 4 equals.
20.
Yes. That was an easy one. 12 minus 3 times 2 equals.
18.
Yes. And then the last one is 15 minus 9 times 4 equals.
18.
Yes. Did you say 20? Is that you, Noah? I can't see your lips moving, so sometimes I can't tell. Okay, yes, 24, because 15 minus 9 is 6. 6 times 4 is 24. All right, you guys can be seated. Some of you are close. Micah, you have 8. Noah, you have 6. Nicholas has 6. Autumn, 5. Okay, so you guys are getting close.
I need
All right, let's poster's kind of blocked. So let's see if we can sing it from memory. Okay, let's sing our 3s and 4s. Ready? 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, almost done. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and we're done. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. 44, 48. I forgot to say that for the times 3. Okay. Good job. Now, today we're going to start learning some different properties of addition. So that just means some rules for adding, basically. Some different rules for adding. So, and probably most of these you know, okay? Now, I tell you what, let's go ahead and open your book to page 29, and we're going to kind of learn them as we go along in our book. So open to page 29. All right. Now, the first, I tell you what, and also open your journal, because we're going to be journaling a little bit. And at the top, you can write addition properties. We're going to learn 2 properties today.
I think I know what they are.
I think you know.
You know why?
What?
Because in 3rd grade I learned all of the properties.
Did you?
Yeah.
What were some of the properties?
Commutative, associative.
Harry, how about you come up and teach the lesson? You want
Yeah,
to?
I know that. Do it.
Okay.
Yes.
He's right.
We did learn it.
Right. So the first addition property we're going to learn, and I want you to think of a community. Okay, so you might have a development where you live and all the houses. Now, the people that live in the houses, if they moved to each other's houses, would you still have the same amount of people?
Yeah.
Yeah. Like in your community, if you have the same people, but like say one day you all trade houses, you still have the same amount of people. So that is what we would call the commutative property of addition. So I tell you what, why don't we write, I'm going to write each one in a house to help me remember.
It's called a house.
Commutative.
Can that be a letter?
Okay. Does someone have a question? Yes, Logan?
Can we draw this in our book?
Yes. This is what we're drawing in our journals. Okay. Mason, you have to move your pen, okay? Because you're just talking for no reason. Commutative. Property. Of addition. All right, so what that means is that when you have a an addition problem, say you have 7 plus 4. What does 7 plus 4 equal? What's 7 plus 4? 11. If I switch the addends,
Oh, yeah.
kind of like I'm moving the houses around. Okay, I'm going to switch them around. 4 plus 7. According to the commutative property of addition, I get the same answer. So what's 4 plus 7? 11. Nicholas?
Oh, I was going to say if you switch them, it's the same thing because
Right.
you can switch them and it's the same thing.
Right. Whenever you're adding, if you can even do a longer one. So let's say we do 2 plus 3 plus 4 plus 5. All right, so we've got 2 plus 3 is 5. 5 plus 4 is 9. And 9 plus 5 is 14. Okay, now I'm going to scramble my numbers up. So let's say we have 4 plus 2 plus 5 plus 3. We should get the same answer. Let's try it. 4 plus 2 is 6. 6 plus 5 is 11. And 11 plus 3 is 14. So, it's true. Whenever you switch addends, you get the same answer, no matter what. All right, so that is the first property we're going to learn about. And the second property is called the associative property of addition. Let me think how we can draw that. All right, so let's just say associative. I'm just going to write it out for now.
Should we write that?
Yes.
We should. It's very important.
I'm not quite sure how to draw it. Maybe once we learn it, you guys can give me an idea how we could draw it. So, what this means is that when you associate with somebody, that means they're like your friends. Okay? They're your buddies. You associate with them. So, the associative property of addition means if you have a math problem and you associate these numbers together and then add it all up, and then you change who's the friends and associate different numbers, it should still have the same amount. So let's use the example is 3 plus 6 plus 4. Okay, now, the way I associate numbers into friends is to put parentheses around them. That's kind of like keeping them in a little huddle, like a football huddle. All right, so let's say 3 and 6 are friends. Now, the parentheses mean to add those numbers first. You always add what's in the parentheses first. So, what is 3 plus 6? 9. And what's 9 plus 4? 13. Now, according to the associative property, I can take those same numbers, and now in this problem, 6 and 4 are going to be friends. Okay, so now they're in a football huddle. And what do we add first? The
6 in the 4.
Right, we add what's in the parentheses first. So 6 plus 4 is 10. And what's add 3? 13. We get the same answer. So, anybody have an idea how we could draw associative I mean, I kinda did the houses for that, but. Oh, I have an idea, but go ahead, what's your idea?
So I would like circle it
Mm-hmm,
and circle the other one
okay,
for some reason.
okay. I was thinking, okay, so the commutative property, we've got 5 plus 7, and I heard somebody say that equals 12. So what's the related fact if we use the commutative property? Lucas?
7 plus
Right. We're just gonna switch the add-ins. Does 7 plus 5 equal 12? Yes.
This is like a review of circle.
Mm-hmm. Nicholas?
So my teacher called this is called like fact families,
Mm-hmm.
where you can switch them and put them in boxes like division
Mm-hmm.
and multiplication. So how they didn't say the commutative property of addition. They said the commutative property of multiplication.
Well, you can do that in multiplication too.
Yeah. There is a commutative
Right. But we're gonna start with addition.
Okay.
Okay? So for number 2, we have 6 plus 8. And what does 6 plus 8 equal? 14. What's according to the commutative property of addition, what's our related addition fact?
8 plus 6.
8 plus 6. And that equals 14. Number 3, 7 plus 9 equals 16. What's the related addition fact? 9 plus 7 equals 16. Right? It seems easy, but every once in a while you're going to have to know that and remember it. All right, now for numbers 4 through 7, we're going to add parentheses to show making 10. Okay, so actually something I didn't mention with the associative is that you want to try to make friends of numbers that equal 10. Because it's so much easier to add 10 plus another number, right? Because 10 plus 9 is 19. 10 plus 6 is 16. 10 plus 1 is 11. It's easy to go off of 10. So when you're adding, you want to try to find numbers that equal 10. So for number 4, we have 4 plus 6 plus 8. So which two numbers would we put parentheses around to equal 10? Okay, Jacob?
6 and
Right, 4 plus 6. So that equals 10, and what's 10 plus 8? 18. Autumn, do you have a question?
No.
Oh. Isn't that so much easier than adding 6 plus 8 is 14, and then 14 plus 4 is 18? Just a little bit easier to add with 10.
Yeah.
Okay, number 5. We have 4 plus 3 plus 7. Okay, which two would equal 7? Autumn. Good. So we add those first. 3 plus 7 is 10 plus 4. 14. Number 6. 6 plus 5 plus 5. What two numbers? What two numbers? So you can just tell me the answer. It takes 5 plus 5. So 5 and 5 is 10. 10 plus 6 is 16. Number 7. Everyone keeping up?
Yep.
Okay, we're in our book on page 29 now. Okay, yeah, we're right here. Sorry. Yeah, we're up here in the book. You didn't have to write all those out. Okay, number 7 is 2 plus 8 plus 3. So which two digits added? 2 plus 8. So 2 plus 8 is 10, plus 3 is 13. Good. Now, we're going to use that same thing we did here, but we're going to go vertically. Try to find two numbers that equal 10, and it'll help you add. Okay, so for number 8, we have 6 plus 4 plus 5. Which two numbers equal 10 when you add them? 6 and 4, so that's 10, and then plus 5 is 15. Well, you don't have to do parentheses when they're vertical, just use your eyes to try to find the two digits that would equal 10. So just write the answer. 6 plus 4 plus 5 equals 15. Right, number 9. Okay, now sometimes they don't equal 10, but 5 plus 4 plus 3.
13. 12.
Right, so in this case, there aren't any two digits that would equal 10 together. So you just need to add 5 plus 4 is 9, and 9 plus 3 is 12.
No.
And then number 10. Which two digits make 10?
7 and 3.
7, 3, and then plus 5 is
15.
15. Okay, and then number 11, they don't equal 10, but so we'll just have to add. So 5 plus 4 is 9, and 9 plus 8 is 17. Good. Okay. Now, right for numbers 12 and 13, it says write the missing number that completes the fact family. So that's what you're talking about, Nicholas.
Oh, yeah.
All right. Fact families are, it's just any family number sentence. 1 plus 2 is 3. Makes 3. Okay. So, write the related facts for the fact family. So, for number 12, what other digit can we put in that blank so that they would all work together in a problem?
18.
Okay, well,
You could do that.
I guess but we don't really learn 18 plus 9. 8, so what other digit can we put in there so that when we do an addition and subtraction sentence, it would work? 0. So put in the blank, put 0. And then we have 9 and 9. So who can see two addition math facts that we could write? Jacob. Okay, 9 plus 0 equals 9. Good, because we're going to use these three numbers and we're going to write, say it again.
0 plus 1.
Right, and then we could switch our add-ins.
Yeah.
0 plus 9 equals 9.
Or 9.
Okay, so those are two addition. Who can see two subtraction math facts? Micah, give me one.
9 minus 9 is 0. And then minus 9 is 0.
Okay, and then Brayden, what's the other one?
I was going to say what Micah just said.
Oh, did you say both of them?
But they can only do 9 minus 9 is 0. No.
There's another one.
No.
Logan?
9 minus 0 equals 9.
Right.
Yeah. Yep.
Okay, now the commutative property does not work with subtraction though.
No.
Because you can't say 0 minus 9 equals 0. You can't switch your numbers in a subtraction problem. Only addition and multiplication, yes. Oh, okay. So let's do the next one. we've got, what number? 7 and 13. Jacob, 6. Okay, somebody give me one addition fact. Brayden?
6 plus 7.
Equals
13.
13. Good. What's another addition fact? Marissa?
7 plus 6.
Right. Equals 13. Who can give me a subtraction? Dana.
13 minus 6 equals 7.
Good. And Mackenzie, what's the other subtraction? Can you say
13
that?
minus 7 equals 7.
Great.
Just like division and multiplication.
Right. So this is like this is a family right here. All the same numbers. Jacob?
I have a trick.
Okay.
So, like, say you have 6 and 7 and 13.
Mm-hmm.
And sometimes you can get it to make a diagonal line if you're simple.
Oh yeah, you're right. You could
So I just
do your numbers
look
diagonally.
and see if I can see a diagonal line, and then that's how I check it.
Okay, that's smart. Okay, yes sir.
So it would be, on division, it would be 13 divided
Right. Well, you
by
have to
7
have.
equals 6. Yeah. And you can
Well,
switch it.
Yeah, it'd be, you would use the answer to a multiplication and it's slipping. You have your factors and that equals, I cannot think of that.
Yeah, my teacher explained.
So if you had 4 times 4 is 6 equals 16, you would do 16 divided by 4 equals 4.
Yeah.
Right.
And you can switch the other two numbers.
Right. Okay, number 14. We are going to write the related subtraction fact to find the missing addend. So an addend, there are numbers in your subtraction problem. Write the value for n. Okay, so we've got 9 plus n equals 17. Okay, so what we just did before, like our fact family, we need to write this as a subtraction family. Jacob, what would it be?
17 minus 8 equals 9.
Okay, well don't say, it would be 17, and then let's do minus 9 equals n. Well, I guess I actually want to put n here, okay? Use these here, 17 minus 9 equals n. N is the number we're searching for. Okay, we replace the number with a letter. So, what does n equal? 8. So, you know what this is? Actually, this is doing algebra. You're doing simple algebra here. Okay? Alright. Was that you? Okay. Move your pen. Number 18. I'm sorry, number 16. N plus 5 equals 12. Okay, let's write this as a subtraction problem. Autumn? Right, 12 minus 5 equals n. So what does n equal? 7. Because 12 minus 5 is 7. N equals 7. Alright, let's go ahead and do this last chart. Write the rule and complete the table. So, you have to figure out what rule they used to get the numbers. So, the rule is M, and we have to figure out if they added or subtracted, and then what number did they add or subtract. So, M 18, 22, 29, 33. Does anyone see a pattern? So if, like for instance, let's fill the M in with the 5. If M is 5 and N is 9, what did we do here? Did we add or subtract, and what number did we do? Same, and it's same with all these. If M is 18 and N is 22, what's the rule we use? If M is 29 and N is 33, what's the rule? It's all going to be the same rule. Did they add or subtract? They added, and how many did they add? To get from here to here, how many numbers did each one add, Nicholas?
4.
4. Good.
I actually saw that on the last one, 29 plus 33.
Yeah, it's the same, because you have to add 4 to 5 to get 9, add 4 to 18 to get 22, add 4 to 29 to get 33. So let's complete the chart. If we have 37, use the rule, 37 plus 4, what would N be? 41.
That works.
If M is 76, and we use our rule, we're going to add 4, what would N be? 80. Good. You guys got it.
Just like,
Very good. So, you guys did some simple multiplication, or simple algebra.
okay.
All right, I tell you what we're going to do. We're going to save the back of our page for another time. Probably tomorrow we might use it for some review. Okay, so you can put your book away.